Hello, everybody. Good evening, good morning, whatever it may be, wherever time you're watching this video. My name is Jy'Den-Myles, and I'll be teaching you about the exponent power properties. The objective of this YouTube video is to help you understand what the exponent properties are and the exponent rules. After I've explained this to you, what the exponent properties are and the exponent rules, I'll show you how to solve a couple. I'll show you how to solve a couple because sometime in the future you will most likely have to solve some of these questions in assignments, assessments, or tests. So to learn and understand the exponent property is not a difficult thing, but applying it to actual questions that you might find on assignments or tests can get quite difficult. But don't worry, the whole point of this YouTube video is supposed to make it super easy for you to understand. So first, let's look at what the exponent rules are. We're going to go ahead and look at rapidtables.com, and it's going to easily explain us what these are. There's the product rules, the quotient rules, the power rules, the negative exponent rules, zero rules, and the one rules. These are the rules that we will be going over today. So first, as you can see, with the product rules. Now, what does product relate to? Product relates to multiplication, which is why there are multiplication symbols here. So how this one goes is you're basically going to have, a number and an exponent times a number and an exponent, right? And so it's going to equal something. And how we're going to get this answer is by doing this process where we're going to, instead of just multiplying both the numbers and the exponents, like how you would do it if it was a fraction, you would multiply the denominator and the denominator. What you're going to do here is you're just going to add the exponents, as you can see here, n plus m. We're going to put these together, and then you're actually going to add them together, and that's going to be your new exponent. You're going to do, how you do with your numbers. So we're having a quick example right here where we have 2 to the power of 3 times 2 to the power of 4. Now we're going to add 3, and we're going to add 4. Now 3 plus 4 is 7. 2 to the power of 7 is 128, which is how we get this answer right here. Next is the quotient rules. What does quotient relate to? It relates to division, which is why there are division symbols here. We have a to the power of n divided by a to the power of n. Now, instead of how we did it in the product rules, where we added them, we're going to subtract them. You know how it's kind of like how we're doing inverse operations, how multiplication is the opposite of subtraction, and division is the opposite of multiplication. So what we're going to do here is we're going to subtract these instead. Now we're going to look at our quick example. 2 to the power of 5 divided by 2 to the power of 3. Now we're going to look. What is 5 minus 3? It's 2. Now we have 2 to the power of 2. This is pretty simple, probably the easiest one out there. 2 to the power of 2 is 4. Pretty simple, easy way to get your answer. Next, we have the power rules. As you can see here, we have 2 to the power of 3, but it's in a parentheses, and then you have a 2. Now, this might look really confusing than all the other ones, but that's what the point of this video is to make it easier for you to understand it. What you're going to do instead of adding them and instead of subtracting them, what you're going to do is you're actually going to multiply them together. Right, so when you see the parentheses and the 2 is outside, the 2 is raised to the numbers inside of the parentheses. Whenever there's a number raised to a number and an exponent that are inside of parentheses, you're going to want to follow the power rules. You're going to want to multiply both the exponents in the equation right here. So 3 times 2 is 6. Then we have 2 to the power of 6. Which is going to get you 64. Pretty simple. Right? Actually, what we're going to do is we're going to skip over negative exponents. We're going to go straight to zero rules. Now, zero rules, we also have to, they're pretty simple, but just to, make sure everybody's aware of these and understanding these, what you're going to do is you're going to have 5, you have 5 right here, you have 5 to the power of 0. It's going to equal to 1. Just 1, nothing less, nothing more. It's not going to equal to 0, it's not going to equal to 5, it's just going to equal to 1. Okay, just to resume really quickly, we're going to kind of speed through this last area, just because it's particularly easy, particularly simple. You should probably already know these things, but if you don't, that's completely fine. We're all here to learn new things. So I'm just going to go resume back to our zeros rules. We have 0 to the power of 5 is going to be equal to 0. It's going to be that every single time, no matter what. It can be 0 to the power of 1,000,000, 0 to the power of 3,000. No matter what it is, it's always going to be 0. 0, 0, 0, 0, 0, no matter what. Okay? Now moving on to the ones rule. 5 to the power of 1 equals 5. Now, kind of the same thing. Not really, though. Right? We have 5 to the power of 1. 5 to the power of 1 is going to be 5, meaning that 3 to the power of 1 is going to be 5. 1,000,000 to the power of 1 is going to be 5. 8,000 to the power of 1 is going to be 8,000. Whatever number it is, to the power of 1 will always be that exact same number, no if, anything buts about it. Going on to ones rule, is this example right here, or how this one rule work is the same of how this 0 rules work. 1 to the power of anything is always going to equal 1. That's just how it is, because no matter how many times you multiply 1 by itself, it's always going to equal 1. Same thing goes with there. Same thing goes with the 0. No matter how many times you multiply 0 times 0, however many times, it's always going to equal 0, right? So pretty simple, right? So now the next thing that we're going to go do is move into questions. By this time, you should understand some of the basic fundamental understandings of how it works, and now we're going to apply them. Now, while I'm doing this, you can always, take a little, take a step, take a break away, anything that you need, while I'm going through the problems, so you can do them yourself. But I do want to make sure that we do get the same answers. And you can always use a calculator if you want. Calculators are definitely acceptable here. If you just want to, get some little quick information, you can use a calculator if you wish. But let's go ahead and get started. So first problem we have here is 4 to the power of 2 times 4 to the power of 3. Now we have to find out which exponent rule is this. Now, when we go back to our list of exponent rules that we just talked about, these are the most common ones, the ones I showed you: the product rules, quotient rules, power rules, 0 rules, and ones rules. It is actually going to be the product rules, because it is 4 to the power of 2 times 4 to the power of 3, right? So what we're going to go ahead and do is we're going to go ahead and add these two. Now, 5 times 2 is pretty easy. We all learned this literally elementary. 5, not 5, 3 plus 2 is 5, right? So that's going to be 5 right there. Then we have to do 4 to the power of 5. Now, you can do this on a calculator. It is a large number. Two of these are larger numbers, but that's completely fine. These are just some quick examples just to show you how these operate. You guys can pause the video and give you guys a second on how to do it. So the answer is 1,024. So 1,024. Bam. Now on to the next one. 2 to the power of 5 divided by 2 to the power of 3. We have to find out which exponent rule is this. When we look at it, it's the quotient rules. 2 to the power of 5 divided by 2 to the power of 3. Now we have to subtract here. Instead of adding, we subtract here. So we're going to go ahead and subtract 5 to 3, which is going to get you 2. So then you're going to have 2 to the power of 2. If you don't know what 2 to the power of 2 is, I'm going to tell you right now. You shouldn't even need a calculator for this. It's 4. Simple as that. 2 times 2 is 4. Okay, because you're doing 2, because it's showing this is what it's going to be, right? Because you're subtracting it. 2 to the power of 2, which is 2 times 2. Because when you're doing it, it's pretty much just to show you in expanded form, right? If I had to the power of 4, it would look like this: 2 times 2 times, oops, it's like that. 2 times 2 times 2 times 2, 4 times. But since we're only doing it twice, it's 2 times 2, which is 4. So the answer is 4. As simple as that. Now, we're going to go on to the next problem, which is in the power rules section, right? So we have 3 to the power of 4, and then we have 3 to the power of 4 to the power of 3. Now, we showed you how to do this. Instead of subtracting it or instead of adding it, you're going to multiply the two exponents. Multiplying these two exponents is going to get you 12. Now, 3 to the power of 12. Use a calculator for this. It is a really big number. just go ahead, pause the video. Hopefully now you've gotten your answer and we can share the answers now. So the answer that you should have gotten was 531,441. Yes, that is a very large number. It's probably not typical for the answers that you might see on a test or a quiz or assignments or assessments, but it is what we did for this one. You know, we want to spice it up a little bit, but it's perfectly fine. You can do it on a calculator, perfectly fine. Now, the next one we have is 7 to the power of 0. Going back to the exponent rules, which exponent rule is this? Now, when we go and look at it, what is a number to the power of 0? Here's a number to the power of 0. 5 to the power of 0. And that's the 0 rule. We have 7 to the power of 0. But guess what? It doesn't matter because we are going to get 1. Because if you're not multiplying anything, then it's 0. So, let me just type in this number really quickly for this question right here. Then we have 0, so it's going to equal 1. Now, we have 0 to the power of 13. 0 to the power of a number is, 0 to the power of a number, right here. 0 to the power of a number is, it's going to end up being 0 every single time. I already explained. It's super easy, super simple. 0 to the power of anything. It can be 0 to the power of 1 million. But guess what? The number will always come out to be 0. Now, I hope you learned something. I hope that now you're enlightened and now you're more educated on exponent rules. So when you continue out to do problems about exponents, you can always think back, which exponent rule is this? Oh yeah, this is the quotient rule. Okay, now that means that we have to now subtract the exponent. Okay, after we have subtracted exponents, let's see what it is. 2 to the power of 5. Okay, so I hope that you'll be in the future that this video has helped you become quicker at that and has helped you understand how to do it and become more comfortable with it. That is the entire point of what this video is supposed to do and the entire point of what this podcast was supposed to do. Now, I was really glad, but for right now, I'm logging off. See you guys later.